People. Here we are looking at Prim's algorithm for minimum spanning tree. Rather than showing you the actual algorithmic implementation, I want to show how you can produce the conclusion of Prim's algorithm and find out the minimum spanning tree. So here I have the undirected weighted graph, and I have drawn the corresponding weight matrix of the vertices. So let's begin. So with the Prim's algorithm, you can start with any vertices. Let me randomly choose 5 v5. So I'll mark those and highlight those. So what I want to do now is go through the row v5 and look for the minimum value, and which I can see is 5. So I'm gonna mark that, and that will be our first edge to the minimum spanning tree from b5 to b3. Alright, now let me mark those columns and row of vertex v3. So now what we are going to do is we are going to find out the minimum values of those selected ones. Since infinity is equal to infinity, so I'm not going to do anything with that one. So between 8 and 7 is the minimum, so I'm going to take off the 8. And one thing I want to tell you right now is, if some cell is crossed over by highlighted column and rows, so we'll simply ignore that one. It simply means that vertices are already included on our spanning tree. So here you go. So between infinity and 15 is the smallest one, so I'm gonna take off the infinity off the table, and between 8 and 8 they are equal, so I'm not doing anything right now. With the 9 and infinity, I'm going to take off infinity since it is greater than 9. Now among the remaining ones, I'm going to look up for the smaller value. So I can see that 7 is the smallest value, so I'm going to highlight that one. So our v5 to v2 is going to be our next edge on the spanning tree, and here I will go ahead and highlight the vertex v2 containing element. Okay, now again, like the last time, I'm going to compare the smallest value among the selected ones. So I see that 7 is the smallest one, so I'm simply ignoring those two infinities. Since 0 is crossed out, I'm taking up those. 7 is crossed off, so I'm taking that off. 8 is crossed off, I'm taking that off. 7 is crossed off, taken off. So now on the remaining one, so between 9 and 15, I see 9 is the smallest one, so I'm going to take off 15. And between infinity 8 and 8 are the smallest ones, so I'm going to take infinity off. And between 9 and infinity is largest one, so I'm going to take off infinity. So now from the remaining highlighted ones, I see that 7 is the smallest value, so I'm going to add that edge from v2 to v1, and I'm going to highlight that all the cells containing v1. So now, like the last time, I'm going to take off all the crossed ones since they are no longer of my use. So from the selected ones, I see that between these two, 5 is the smallest one, so I'm going to take 9 off. And between these three, infinity is the largest, so I can take off that one, but still I have tie between the smallest values between two vertices. And on here I can take off infinity off because it is larger than 9. So now comparing the remaining selected values, I can see that among 5, 8 and 9, 5 is the smallest one, so I'm going to highlight that one and add vertex v1 to v4 on our spanning tree. And now I'm going to highlight those rows and columns of vertex v4 like I did this last time. I'm going to take off all the crossed values because they won't be added again. So from the remaining selected ones, I can see that 6 is the smallest one on this column, so I'm going to take off 8. And between 9 and infinity, 9 is the smallest one, so I'm going to take off infinity. So here I can see that between 6 and 9, 6 is the smallest one, so I'm going to highlight that one. That means vertex v4 to vertex v6 is going to be added to our spanning tree. So I take off now v6 column and v6 rows, and like the last time I told you, I'll take off all the crossed ones, or I'll take off the largest one. So all the crossed ones are taken, and between 9 and 11 I can see that 9 is the smallest one, so I'm going to take off 11. So here only highlighted element left is 9, so I'm going to select v7 rows and columns. So I can see that for 9 is from v5 to v7. So let me add that. And so for the sake of the trick, I'm going to remove all the crossed ones. So it looks like all the vertices are added to our spanning tree. Let's stretch it out on our graph over here. So I see v5 and v3 are connected, v5 and v2 are connected, and v2 and v1 are connected, and v1 and v4 are connected, v4 and v6 are connected, and v5 and v7 are connected. So this seems to be our minimum tree. Let's find out total cost of minimum spanning tree, which is the sum of all the edges in spanning tree. So 9, 5, 7, 7 and 5 and 6, that will be 39, which is the solution. Thank you guys.